Hello and welcome to the channel. Today we're going to be talking about some first impressions of the RTX 5090 for reinforcement learning. And I'm going to kick this off with a couple of disclaimers. The first is that this video is not sponsored by anyone. I am not popular enough to have sponsors. So this is all hardware that I have bought with my own money, and therefore I have a pretty strong opinion of whether or not it's worth it or was worth it to me. The other is that I do not have a good professional test bench setup. In some cases, we're going to be talking about cards that were tested. Cards and tests run in the same machine, so we're going to have processor parity. And in other cases, some of the numbers that I'm going to talk about are from cards run in different machines with different CPUs. It's not ideal. It is a side effect of having run these tests at different times in the machines that I actually use these cards in. So we're going to be talking about the 5090 comparing to the 3090 and the 3060 because that's what I've had on hand. So I got the Gaming Trio Overclock Edition from MSI. Not because there was anything special about this card for reinforcement learning. It just happened to be the card that was closest to MSRP when I finally decided to pull the trigger and buy one. The first impressions of the card itself, it was a little lighter than my old 3090. The 3090 felt like a big heavy block of metal. I had the Founders Edition, that might have contributed to it. But I've heard other people, refer to 3090s and 4090s as being quite hefty. The Gaming Trio from MSI really feels like you're holding air. It's quite plasticky. It's very light. If you're looking for that premium heft and feel, it really doesn't deliver on that front. But it does well everywhere else. In the actual functionality of the card, it's been great. The initial setup in Linux was interesting. So when I set the card up, attempted to boot, I got as far as the login page, attempted to log in, and black screen, nothing. Finally ended up booting into safe mode, and I had to figure out that the new older NVIDIA drivers, and we're not talking about drivers that were that old. I have Ubuntu 24 is what I use for my primary system, and I only set up this particular machine 4 months ago maybe, so everything was relatively recently installed and updated, but the drivers that were loaded at that time would not boot with the 5090 installed. So I actually had to go out and load new driver, load the absolute latest drivers from safe mode, from the rescue mode prompt, and then I was able to get in and boot up the machine. Getting my projects running, so I primarily use PyTorch, and getting my projects running was pretty simple. I did have to come into my requirements TXT and had to change from my old CUDA install to 129 and uninstall Torch Vision, and Torch Audio from all of my projects and reinstall with the new PyTorch index URL. But once I did that, most of my projects worked out of the box. So let's talk about how well those projects have worked. And I'm going to be talking about a few different tests I've run. The first centered around the Pong environment run in my RL for Beginners project. This is a project that's out there on YouTube. I've made videos about it. That's why it's called RL for Beginners. But ran 1,000 episodes, and I ran those with the 3060, 3090, and 5090, all with, I can copy this up, all with the replay buffer running on system memory, not GPU memory. What I got here is with the 3060 running on this one was paired with the Intel 12700K, which is a 12th gen i7. The others were with the 9950X3D from AMD. But with the Intel 3060 combo, we had the RL for Beginners project running in 2127 seconds. With the 3090 and 9950 X3D combo, it ran in 1477 seconds, so significantly faster than the 3060. But the jump from the 3090 to the 5090 was only about 15%, which threw me off a little bit when I first saw this. This was something where I was expecting, and here I can zoom in a little bit too, but this is something where I was expecting to see a much bigger jump, and I only saw 15% faster, which was a little disappointing. Again, not sponsored. I went out and bought the card. So for something that was basically $1,600 more than what I spent on my 3090, I was really hoping for this number to be like half the, the time taken. And what we got is about 15% faster. Now, why is that? Let's talk about it for a minute. So the primary problem that we're running into here is that for reinforcement learning, and that's why I wanted to talk about GPUs in the context of RL. This is not a general review of the 5090. It is specifically for people who are doing what you're probably doing if you're on this channel, reinforcement learning. It really doesn't use that much of the GPU's overall power. If I run here, let's go ahead and get NVI top up first. And I want to call out a couple things. So we're using 92 watts of power, 93 now, just with me recording this video. We're using 20% of the GPU and 17% of the memory. That's not too crazy because it's recording at 4K and doing some transforms, and like this isn't bad. This is not surprising me. So 92 watts of power, 21% utilization. If I come in here and run the train.py on my RL for Beginners project, we jump up to 59%, so another 30-ish% used, and we jump up to 134 watts of power. So we really only used, according to NVI top, 40% of the GPU in addition to what we were using before, and we only added about 40-ish watts of power to our overall power consumption, which is almost nothing out of the total that we could be using. This thing has a top power consumption of 575 watts. We are using 136. So very low power consumption, very low to utilization, only about a third of the memory. A lot of reinforcement learning projects don't use the whole GPU. Just looking at this, you would probably see exactly the same speeds if you were running on a 5080 and maybe even a 5070 Ti. I don't know. I don't have one to test, but you'd probably see similar scores here because, we're just not using that much of the card. What else is interesting here? I think the 5090 has gotten a lot of bad press around power usage because it does have the ability to use a lot of power. But what's interesting about that is that it's doing more with more power. When you're gaming, it's rendering more frames. It's, doing DLSS. There's a bunch of stuff that goes into the fact that it's pulling a lot more power than previous cards. But when you have something like this, a reinforcement learning workload, where it's doing more in the sense that it is running the workload a little faster, but it's not doing that much more. Like it's doing the same workload 15-20% faster. You actually get lower power usage than you get out of something like a 3090. And I'm going to show you that. So over here, remember, we were already at 90 something watts just hanging out, just with me doing my recording. If we go over to my lab server, and my lab server is the one that currently has the 12th Gen i7 and the 3090 in it. So if I run an NVI top, we can see the 3090. So we're idling right now at 19 watts of power. And if I come over here and look at the RL for Beginners project and do a conda activate RL for Beginners. And it would probably help. Let's see, what did I call that? Conda env list. Let's see, this is probably Pong. Oh, wrong one. And it looks like right up here, I did RL for Beginners with dashes. That'll teach me to be inconsistent. All right. So now, if I run my train.py over here, we should be kicking off the RL for Beginners project, which, for a little bit more information, this is a Pong environment. We are processing images and using those images for reinforcement learning. So it's relatively heavy as general, programs go, but it's not like it's the heaviest possible algorithm, but it is doing some image processing. And what we see here is that we jumped from 19 watts to 112 watts. So we're, running, we basically saw a 90 watt increase over here for running that project versus a 40 watt increase over here. And if we go to one of our more complex projects, so let's talk through a couple more of these. So that's how that went. If we look at some of these other numbers I ran, so this run was a no GPU/training. So I did, I just ran the environment to see how much of the runtime was the GPU was, interfacing with the GPU. So with no training at all, it ran in 254 seconds. So that means that up here, about 1,000 seconds were GPU interface. I also ran a test down here where I loaded the entire project's replay buffer up on the GPU. And that ran in 1,058 seconds. So this was the first serious performance bump I saw and represents something that might be interesting. If you're working with projects that are larger than your buffer size, or larger than your where your buffer size is larger than your GPU memory, then you'll see more of a win from something like a 5090, or just a general upgrade to your card. If you have a 3060, you're going to see more of a bump jumping to something where you can load the entire thing onto GPU VRAM than versus running it where you're bouncing data back and forth. So that was interesting to see. So just no change in architecture. We got a 15% bump. When we changed over to using the VRAM on the GPU, that took another 200 seconds off. So there was a more considerable bump there. Coming down here, this test was interesting. So SAC Ant Maze, this one is, RL for Beginners, we're processing images. SAC Ant Maze, which is Soft Actor Critic running the Ant Maze Mujoko environment, is returning a state that is a vector of numbers. It's just returning blocks of numbers to represent the state. It's not returning any kind of images. So what's interesting there is running the 3090 versus the 5090, we actually see the 3090 took less time. And I do think that's a little bit of a fluke. I think this was, this is within margin of error as to which one could have come out on top. But I think what this is telling us is that our GPU is not the bottleneck. If we are running with images, it is, and things move faster on a faster GPU. If we're just training in small batches, I don't remember if my batch size was 32 or 64, but relatively small. So if we're training in small batches of numerical data only, and the environment takes a while to run, this is a Mujoko environment, then the GPU doesn't seem to matter all that much. And we see up here, we saw 1,924 seconds, which I don't have things configured in a way to test this, But I suspect that that slowdown was not so much the 3060 as the older Intel processor, and the fact that we are, again, running a Mujoko environment on, which is a little heavier, takes a little more, power to run on that older 12th gen i7. So I think that's why we see that big jump there. The PET's Lunar Lander environment is interesting. So this is one that I don't have as clean of a test as I'd like. I would love to say that I ran this one both on the AMD, but I didn't. I got stuck running them on the way I have the systems configured. One of these ran on the Intel processor in the 3090, and the other one ran on the 9950X3D and the 5090. But it is where we see the most startling difference. So the lower power system here, you ran in 728 seconds, and the 9950X3D with the 5090 ran in 338 seconds. So we are hitting less than half the time here to run the PET's Lunar Lander environment. And PET's is a heavier algorithm. It's not very computationally efficient. What PET's is basically doing, and I will have a video about this at some point, is it is randomly selecting from several hundred possible futures. It's trying to guess 15 steps ahead, and then it's trying to predict all of those possible futures. So there is a ton of prediction and inference going on here, and it is much heavier than some of these higher, some of these other environments. PET's is the only algorithm where I've ever had to back down some of my parameters to get an environment execution to run in what I would consider human normal time. So to not have it look like it's running in slow motion. Most of the time, you've got to slow your environments down if you have to do anything. With PET's, I had to actually limit some of the processing because it wasn't finishing fast enough to run and make it look, normal while I was trying to watch test runs. And this one, you actually see a little bit of a more startling difference. For if we come over here and say PET's Lunar Lander, let's activate that environment, and then we're going to do PET's Lunar Lander, and again, let's look at where we are. So we're running at 92 watts with 23% utilization, we'll say. Train.py. And you'll notice we're now at 83% utilization, so we are using significantly more of the GPU. And we're still only running at 132 watts of power. If we come over here and do the exact same thing on our 3090, so let's go to PET's Lunar Lander. And we're going to run the train.py. We've got 139 watts used running PET's Lunar Lander, and we're bumping up to 160 versus 134 over here, which was a really interesting result to me. So these cards do get a lot of hate for their power usage, for being a card that can use 575 watts during gaming. But I think what I'm finding in my own testing is that for reinforcement learning, not only is the 5090 doing this run in half the time, but it's doing the run in half the time with less power used. So, and again, remember that this was 90 watts with just me doing my screen recording. So we added 44 watts over here, and we added, 130 watts over here for the older, supposedly more, energy efficient 3090, or at least lower power 3090. Ends up not being more energy efficient for what we're doing. So NVIDIA actually did a pretty good job with those two, a couple of generations of architecture later, in running the same workloads faster and with less total power. So let's go and see if we can answer 3 core questions now. The first is the 5090 a good card for reinforcement learning? And without a doubt it is. It is a incredibly powerful piece of hardware. I love having it for what I'm doing. It makes things run faster. It is fairly quiet. It is a great card to have for reinforcement learning. Does it use significantly more power? We found the answer is no. It uses less power for the same workloads. Probably more power if you're gaming. Like, that's not the use case I'm talking about. But for reinforcement learning, it uses less. But then the final question I want to talk about is, do you need one of these or any 50 series card for reinforcement learning? And the short answer is no, you really don't. If you are just getting started or even trying to build a pretty substantial RL workstation, then the answer is that a drastically cheaper card is fine. For a lot of what I'm doing, really until we get down to the Pets Lunar Lander, and actually let's just go ahead and I'm going to kill that run so that it's not just sitting there heating up my my office. But you know, even if you're building a relatively beefy machine for reinforcement learning, you can do that on previous gen hardware and it's fine. You can do that with cheaper cards and it's going to be fine. If we think about the fact that for most of these we were using 40-50% of the card, it means that you could probably get like a 5080 and it would have identical performance. I can't test that. I don't have a way to validate that, but it makes sense. If you're using half of a 5090, a 5080 is going to have the same clock speeds. It's going to have the same architecture improvements. It's just a less powerful card. You're probably going to see the same results. Even if you drop down to a previous gen, if you get a 3090, you know, with no architectural changes, I only saw a 15% change. Now, making some architectural changes, I saw a little bit more. But for most projects, even for, you know, image heavy, you know, Q-learning, SAC, you know, DDPG, things like that, you're probably not going to see a massive change. You might see a massive change with other applications, but for those types of algorithms, you probably won't. For really compute-heavy algorithms, you will see a significant uplift. That's what I'm finding here. The total system cost, the difference between these two, this was probably a $2,000, $2,100 system in total. And then this was probably a $4,600 system in total. So it really comes down to a question for you, for your use case. What's worth it? And for some people, this is probably worth it. If this is something that you know, are really serious about, you spend a lot of time doing, you don't mind putting some money into it, for some applications you can see a significant uplift. But you absolutely don't need it. We're talking about saving time here, not making something that is fundamentally incapable of doing the task. You know, I have done, for most of my videos that you may or may not, you may have seen, what I'm doing is I've been using my 3090 as my primary, you know, on my machine GPU. And then I've had the 3060 parked off on my lab server, on my training server. And I'll do most of my development on the 3090. And then when it's time for the thing to sit there and train for 10, 12 hours, I would just park it on the 3060 and let it sit there and think. And there was nothing wrong with that hardware configuration. So, is it worth it for the money? Depends on you. Probably not. Probably, you know, at this point, it is the 50 series cards are very, very expensive for what you get. Is it a great card? Absolutely. But you can also do a whole lot of reinforcement learning and really get into this hobby with drastically cheaper, even previous gen graphics cards with absolutely no trouble. So with that as a final thought, I am going to wrap this one up. Good luck GPU shopping, and until next time.